Chapter 1, Section 3 in geometry is measuring and constructing angles. Okay, so first off, definitions we're going to be talking about is what is an angle, vertex, the interior of an angle, the exterior of an angle, what a degree is, acute, right, obtuse, and straight angles, congruent angles, angle bisector. The one postulate that we have, there's two in this section, but again, like the last one, we're just going to use one of them, is the angle addition postulate, or 1-3-2. Okay, so to start off, an angle. All an angle is are two rays that have a common vertex. In this case, I drew two segments with a common vertex, but if this line extended on forever and this line extended on forever, it would be a ray. Okay, so I'm going to label the points here. Display label points. Okay, now we would say this is triangle ABC or triangle CBA. Okay, the vertex, or the B here, the vertex is basically the common endpoint of the two rays, is always labeled in the center. So when I name it ABC, I know that B is the vertex. Now I could also call this angle B because B is the vertex. Okay. Now the interior of an angle is basically all points in between the two rays. So everything in this region, any point in here, that's the interior. Everything outside of it is the exterior of the angle. Okay. Now, a angle is measured in degrees, and what a degree is it's 1/360th of a circle. So there are 360 degrees in a circle. So we use those to also measure angles. So if I measure this angle, measure angle, the measure of angle ABC would be 47.76 degrees. All right. Now, angles are distinguished by basically four characteristics, okay, dealing with their measure. An acute angle is every angle between 0, so if I brought this all the way down, between 0 and 90 degrees. Okay, so that's pretty close. This angle, alright, so every between 0 and 90. That's an acute angle. Now, if it was perfectly 90, so I'm going to make a perfect 90 degree angle here. I'm going to draw a segment, point, highlight, construct perpendicular line. There we go. Put a point here, label, measure, angle, boom. Angle DEF is a perfect 90 degree triangle. We call this a right triangle. So anything less than 90 is an acute, perfectly 90 is a right triangle, and anything over that, anything over 90 and between 180 is what we call obtuse. It would be an obtuse angle if it was between 90 degrees and 180. And lastly, we have a straight angle. Okay, let me show you what this looks like. GEF. If I measure this angle, it's 180 degrees. We call it a straight angle because it forms a straight line or a line segment. E is the common endpoint here because it is also labeled in the middle. G and F are the sides. So EG would be the side, and F and EF would be the side of the angle. So you have those four things. You have an acute angle, a right angle, obtuse, and a straight angle. Acute is less than 90. Right is exactly 90. Obtuse is between 90 and 180. And a straight angle is 180 degrees. All right. Now, congruent angles. Okay, from the last section, you know, congruent means the same as, or the same measure. So, I'm going to delete all this. Congruent angles are simply angles that have the same measure. Their measurements are the same degrees. So let's make an angle here. Highlight this angle, construct, copy, edit, paste. I'm going to move this. So I have two angles here, label the points. Alright, let's measure angle, measure this one, measure angle. They are both identical. Angle HIJ and angle KLM are congruent because they have the same measurement. Now, we can display this visually by drawing little angle markers here. They're basically tick marks for angles. So if you see this, these two symbols, it means these two angles are congruent. Okay. Lastly, we have an angle bisector. Okay, and all an angle bisector is it splits the angle in half. So if I took, let's see, this angle, if this segment right here split angle HIJ in half. So that means that the angle here was exactly half of 54.07 and this was exactly half of 54.07, then this segment is an angle bisector of HIJ. Okay. Alright. So those are my definitions. They had angle, vertex, interior of an angle, exterior of an angle, degrees, acute, right, obtuse, straight, congruent angles, and an angle bisector. Now for the angle addition postulate. So let's delete this. Delete these points. I'm going to draw an angle here. Let's label. Measure the angle. So I have angle NOP. Its measure is 138 degrees, or 138.7 degrees, so it's an obtuse angle. I'm going to draw. Now, what the angle addition postulate says is that you have any point in the interior of an angle. So this point Q, is in the interior of NOP. Any ray, destruct ray, or line segment, here let's undo that, let's have it go the other way. So let's have O and Q, construct ray, there we go. Any ray that runs through that point, if I take the measurement of the angle formed by that point, so NOQ, measure angle, and I take the other one, so QOP, measure angle. Now if I look at the relationship between those two, I take the one angle, let's delete that, number, calculate, I take this angle, I add it the other one. Okay, and there you go. I have the two individual angles adding up to the sum of the total big one. So if I can move this and see the total when I add the two angles together never changes with the total from the NOP angle. So